Okay, here is number 7 on our review for chapters 3 and 4. What the directions are asking us to do for this function is they are asking us to graph. So we have to go through the process of what is this going to look like when we graph it. So the first thing that we're going to do is we are going to determine what it looks like at the end, kind of the end terms test. And when we do that, we look at our negative 2x to the fourth. So a couple of different things that this leading term, it's called the leading terms test. A couple of different things that this leading term tells us is that it's going to look, the ends of the graph, they're going to be going in the same direction, as well as it's going to look similar to a parabola. Now this is to the fourth power, so it's not going to look exactly like a parabola, but it is going to either be going, both of the ends are going to be going up and down, or the ends of the graph are going to be going down. Okay, so our end graph is either going to have both ends of the graph going up or both ends of the graph going down. That little squiggly line in the middle means we don't really know what the middle of the graph is going to look like. But because it's to the fourth power, which is an even power, both of the ends of the graph are either both going to be going up or they're going to both be going down. Now, because we have a negative right here, because there's a negative in front of that, it is going to be, they're both going to be going down. So this is what we're looking for with our graph. In the end, both of the ends of the graph are going to be going down. Now I've kind of made that negative kind of dark, so let's put that negative back in there so that when we start doing our test points and stuff, we won't forget it. Forget that that leading term is negative. So now we know what the end of the graph is going to look like. So the next thing that we're going to do is we are going to find the factors in the solutions. So we are looking for 4 solutions in 4 factors. Now we may have a multiplicity like we did in number 6. We did have a multiplicity. 1 showed up 3 times. But as long as we account for the multiplicity, we're looking for 4 solutions and 4 factors. So the first thing that we're going to do, this has got 5 different terms in it, so it cannot be factored. So we're going to have to use synthetic division. And I always use this negative 12 right here. That's where I start. And I typically always start low with positive 1, negative 1, positive 2, negative 2. Those are the factors that I start with. So I'm going to start this one with negative 1. And we're just going to see if negative 1 is a factor of this and if it will work. So I'm going to write down my coefficients. So I've got negative 2, I have positive 1, positive 11, negative 4, and negative 12. So for my synthetic division. Now just remember, if for any reason one of the exponents is not accounted for, so if we like skipped an x raised to the third power, you've got to put that 0 in. Now ours, we've got x to the fourth, x to the third, x squared, and x, so we're good here. But if for some reason you don't have that, then you have to put that 0 in. So I'm going to go ahead and start my synthetic division. I'm going to bring my negative 2 down. Negative 1 times negative 2 is positive 2. 1 times 2 is, and then I add those two together, 1 and 2, so I get 3. Negative 1 times positive 3 is negative 3. 11 added to negative 3 is positive 8. Negative 1 times 8 is negative 8. Negative 4 and negative 8 is negative 12. Negative 1 and negative 12 is positive 12. And we are left with a remainder of 0. Once we get that remainder of 0, then we're okay. That's what we want. So if negative 1 is a 0 or a solution, that means x plus 1 is a factor. So I have x plus 1. then since I started with x to the fourth, this negative 2 is going to be associated with x to the third. And then I just move down. So then I've got plus 3x squared plus 8x minus 12. Okay? So at this point, we are going to see if we can factor. If we can't factor, we have to do synthetic division again. But if we can factor, we can just break it down into factors. So I'm going to see, is there anything that I can pull out of both of these? Is there any variable, any numbers, or anything that I can pull out of both of those? And there is. I can pull out an x squared. So I'm going to pull out an x squared of both of those. So x squared times negative 2x. Then I've got x squared plus 3. And that looks a little different to us because we've got that negative 2 there, but it works. Having a negative 2 there is going to be fine. What that means when I do the second part is that I am going to have to pull a negative out of the 8x minus 12. So I'm going to go ahead and think about, okay, well, what would I pull out of both of those? Because I do want to end up with negative 2x plus 3. So if I take a 4, because a 4 will go out of both of those, then I'm going to end up with 2x minus 3. And that's not what I want. I want negative 2x plus 3. So if I pull out a minus 4, I'm going to end up with the same thing. So minus 4 times negative 2x, that will give me positive 8x. And negative 4 times positive 3, that will give me negative 12. So it works. It looks different than what we're used to, but it does work. So we have x plus 1, then we have x squared minus 4, and then I have negative 2x plus 3. I'm not done. This can be factored further, so we are going to factor that further. So I have x plus 1. X squared minus 4 is the difference of perfect squares. So I'm going to have x plus 2 times x minus 2. And then my final factor is negative 2x plus 3. So these are my factors. And what I want are my zeros, or the solutions that are associated with that. So I end up with negative 1. That's one solution. Negative 2, positive 2. Those are two more solutions. And this one is going to be, and this last one, you might actually need to put that and set it equal to 0. So I have negative 2x plus 3 equals 0. That's negative 2x equals negative 3. Divide by negative 2, and I end up with x equals 3 over 2. So don't hesitate to write that down if you need to. So these are my 4 zeros. And we're going to use those 4 zeros in order to determine intervals. So I am going to move to the next page, and I'm going to write those zeros down again. So I have negative 1, positive, or negative 2, positive 2. And then I had 3 over 2. Now I just want to make sure those are the right zeros. Negative 1, negative 2, 2, and 3 over 2. Negative 1, negative 2, 2, and 3 over 2. Okay, so we've got our zeros. So I am going to draw my number line. And this represents my x-axis. And so here's 0. Okay, and this is going to help me do my intervals. Excuse me. Okay, so we have negative 2, negative 1, 2, and 3 over 2. That is 1.5. So those are the numbers that we're going to use for our intervals. So my first interval is negative infinity all the way to negative 2. Then I have negative 2 to positive, or negative 1. Negative 1 to 3 over 2. Then we have a small interval, so we're going to have to kind of get a number that's a fraction. And I know we like to avoid that, but we can't. We can't avoid it in this situation. So then I have 3 over 2 to 2, and then I have 2 to infinity. Okay? So then we are going to do a test point inside each one of these intervals. So my test point for the first one, so I'm going to write interval right here so that we know that is the interval that we're talking about. Then here I'm going to write my test point, and then after my test point, we're going to talk about whether or not it's positive or negative, and whether it's above my x-axis or below my x-axis, because that is telling me the behavior of my graph, and that's important when we look at sketching that. So our first test point, we're going to use negative 3. Up again, in between negative 2 and negative 1, we're going to have to use a fraction. So let's do negative 3 over 2, and if you like to use decimals there, that's negative 1.5. And that would be okay to use negative 1.5 as you're doing that. Then we have negative 1 to 3 over 2. I'm going to go ahead and use 0 there. That's going to be our y-intercept, and that's a point that we're going to use on our graph. Also, we're going to have to identify our y-intercept anyway, so we're going to go ahead and do that during this interval. Our next interval is 3 over 2 to 2. That's a very small interval. So we're really going to have to use something in between 1.5 and 2. So I'm going to put down positive 1.75. Positive 1.75. Now in fraction, because we do a lot with fractions, that's going to be 7 over 4. So you can use 7 over 4 or 1.75 for that. Either one of those is fine for us to determine the behavior of the graph there. And then for 2 to infinity, we're going to use 3. Now, I think at this point, one of the easiest things that you could do at this point is to get your graphing calculator. So pull out that graphing calculator. Mine is deep in my backpack, so I am pulling it out. And you can put in that function to your graphing calculator. So take your graphing calculator, you're going to hit the y equals on your graphing calculator just like you're going to graph it, because eventually you're going to use your graphing calculator to graph it anyway. And we are going to type in the original function. So the original function is negative 2x to the 4th negative 2x to the 4th plus x to the 3rd plus 11x squared and I have completely messed mine up, so I have to start over. So I'm starting over. Negative 2x to the 4th plus x to the 3rd plus 11x squared minus 4x minus 12. So it is important that you look back and you check that you make sure that you have typed in the correct thing. So we have negative 2x to the 4th plus x to the 3rd plus 11x squared minus 4x minus 12. Now, you could go ahead and graph it, and you could look and see what the graph looks like. And that's completely fine, because ultimately, you are going to look at that to determine what the graph looks like. But what I really want you to do is I want you to hit second, and I want you to hit table. That's what's right above that. What that does is it's going to give us the values. It's going to give us a table of all these things. So when I have -3, it tells me that the y value for -3 is -90. So that means that my graph during this interval is going to be below the x-axis. Now, the next one, in between -2 and -1, I'm not able to use my graph because my graph, or my table, I'm sorry, is all integers. It's all whole numbers. So I'm going to have to plug in -3/2 when I do that interval. So I can't put anything down there. However, I can look and see at 0 what my value is going to be. So my value is actually going to be -12 at 0. And again, for my next one, for 1.75, I'm going to have to plug that in, but because it's not an integer. But then I can go down to 3 and see that it's -60. So I'm able to see at 3 of my different points without plugging them in what is happening at my graph. So now that I have that, I'm going to go back. So I'm going to hit second, quit, and that's going to take me just straight to my calculator where I'm going to use computation. So before I can get started with this, I need to put in -2 because that's my leading coefficient. Then I'm going to put -3/2 in parentheses. So don't forget, you've got to have everything in parentheses. And then I am raising that to the 4th power. Then I have plus that value, -3/2. And now I am raising that to the 3rd power. Then I have 11. And I just messed it up on my calculator again. Okay, at this point I have entered in the values here for our -1.5 and our 1.75. So now we can kind of see a pattern here, and we have the behavior of the graph before and after in each one of these intervals. So I am going to sketch it out, and then we are going to use our calculator to help us with it. So here we have our x-intercept, or our x and y axis. And we know at the points where it crosses the x-axis. So we know our graph crosses the x-axis at -2. We know it crosses the x-axis at -1, at +2, and at +1.5. So our intervals are telling us what it's doing in between those times. So it is, in the interval of -infinity to -2, we get a negative value. So our graph is below the x-axis during that entire value, during that entire interval. Now our next interval is -2 to -1, and we have +5.25. So our test value is -1.5, and we got a positive. So we know that during this interval, we are above the x-axis. Now, our next test point is x equals 0. So that is where it's going to cross the y-axis. And we are actually going to cross the y-axis pretty far down at -12. So really on the graph that I've sketched, we probably aren't going to even have that there. And so it would be further down where we cross the y-axis. So in this entire interval, we are below the x-axis. And our y values are pretty far down where it crosses the y-axis. But it does give us a good idea of the behavior of the graph. Our next interval, 3/2 to 2, where we used 1.75, is a very short above the graph. So we know it's above, but it is a very small interval. So we know that that's what the graph is doing in that point. Our last interval, 2 to infinity, gives us a negative number, so we know that during that interval, it is also below the graph. So what we have right here is we have the graph sketched out on what it would look like. At this point, I would encourage you to use your calculator and get an idea of exactly what the graph looks like. And so I'm going to pull up a Desmos graph that I took a picture of. And this Desmos graph does give us an indication of exactly what the graph looks like, and shows us exactly where it crosses all the points on the x-axis as well as where it crosses on the y-axis. And so that is how we sketch this graph.